Welcome back to some more geometry. Today we are talking about angles and congruency. So start this out. All right, so let's look at parts of an angle. So it's an angle right here. Let's go back here. The angle is made up of two rays that have the same similar points. So let's talk about what rays are. What are rays? So rays are part of a line. So remember, our lines go infinitely in opposite directions forever and ever. We took parts of a line and called those segments, where we have a start point and an end point. Well, the ray is just that. It has an end point as well, but it doesn't. It goes infinitely in one direction, as you can see, forever and ever. Now, when it comes to labeling these rays, we only need 2 points. So you see here, we always use the end point, and then we use one of the other points. So even though it goes through multiple points, remember, it goes through a unlimited number of points because it goes forever in one direction, so that means there's a forever amount of points that it goes through. But there's two specific ones that's labeled. You only need one. Do not label it PQR. You either go PQ with a ray symbol above or PR with the ray symbol above. You always start with the end point as one of the points. Now, when we talk about opposite rays, we're talking about two of these put together, back to back, going away from each other, all oppositely. But if you really think about it in the grand scheme of things, this is just a line, really. Our opposite rays are just lines when they're formed together. And then we'll talk about straight angles here in a bit. Now, opposite rays here go away from each other. As you can see, they're going to use B as the end point, the starting point here, and then we're going to go through A. So even though the ray is facing towards the left, we still always write the symbol for it as it's going to the right, but we're starting with the end point. So by saying B and then A is saying that we're starting at B going towards A, versus its opposite ray, we're starting at B and going towards C. So that's how you'll label these right here as well. So let's talk about actual angles. So angles are two rays put together. So remember, the rays just have an endpoint that go infinitely in one direction. They just happen to share the same endpoint. So the endpoint here is right here for this particular example. Now, these rays right here are now called sides. They're the sides of the angle, and the actual endpoint is our vertex. Let's switch that color, so it's our vertex. And this happens to be the vertex for all these angles that we're going to talk about. So let's start with an acute angle. An acute angle is anything that's bigger than 0 but less than 90. Now, when we're talking about bigger than 0 but less than 90, what we're looking at is we're looking at the distance between the two rays. So for example, this right here, we'll call this our acute angle. And it is because we're measuring the distance from this side to this side right here. We're measuring that right there, that gap. When that gap is less than 90 degrees, we consider that an acute angle. Now, if that little gap right there is exactly 90 degrees, like this angle right here, and the only reason I know for sure 90 is because when I made this little file right here, I made sure that it was exactly 90 by doing this little perpendicular tool here. All right. Anyways, it's 90 degrees, so we're looking at the measurement from this one all the way to here. That right there is our right angle. It's exactly 90 degrees. It's exactly perpendicular. Actually, I'll go ahead and make that right here. There we go. These two lines are perpendicular, so we have one like that and another one like that. These are exactly perpendicular. Now, when it comes to doing your homework and you're doing some of the work, in there to tell that it's for sure 90 is one, they'll tell you, hey, this is 90. Or sometimes just put this little block right here. It's a little square in the corner. That square indicates that it is perpendicular, meaning it is 90 degrees. So that also works out. Now we look at obtuse angles. Anything bigger than this 90 degrees. So it can be barely bigger than 90 degrees, just barely slanted. That's still considered obtuse. Or it can be quite a bit slanted, as you can see right here. Our example here goes from, we'll use the same ray. Goes from here across this way. Oh, let me redo that again. It starts from here, of course, and then across the ray. There you go. And we're measuring the distance from this ray all the way to this ray right here. That's be considered an obtuse angle. And a straight angle, like we said earlier, of course, is a line. Anything directly, two opposite rays put back to each other. I thought I clicked orange. There we go. Two rays going back to back across from each other. That's considered a straight angle. So we're measuring the distance from this ray all the way to the other ray. So from here, all... There you go. Oh, maybe. Anyways. Again, we're going for the distance from this ray all the way across to the other one. So that right there is 180 degrees. We call that a straight angle. All right, so review real quick. Acute angle, anything smaller than 90 degrees, like this little red one right here. A right angle, anything exactly 90 degrees, like this purple one. A obtuse angle, anything bigger than 90, like this green one. And of course, a straight angle is exactly 180, like this orange one. So let's talk about a couple of some wordings that we're going to be using a lot throughout this. Get confused. So when we're talking about points that lie on the angle, we're talking about the points that exist on those actual individual rays. So we have A, B on this ray, B, C, D on this ray right here. They lie on the angle because they're on it. So once you form a angle, you have what we call an interior part and an exterior part. So interior is anything on the inside of the two rays. Now remember, these two rays go infinitely forever this way and this way, forever and ever. So it kind of forms a barrier between the two sides. We have our interior, anything that's in between the two rays, and our exterior, anything outside the two rays. So if you see outside, inside, or interior, exterior, that's what they're speaking about. So in our example here, you're going to pause and do yourself. Remember, we're going to classify each angle. What kind of angle are these? Acute, obtuse, right, or straight? And you're going to just tell me a point that exists outside of that, so we kind of understand the concept of outside. All right, so hopefully you did it yourself, and let's try this out. So when we're looking at R, X, S, if you look at all these, they have the X in the middle because at the middle term, the middle letter, and when you're labeling these angles, has to be where the vertex is at. So for our example here, we're going from R all the way to X, all the way to S up here. So we're looking at this gap right there. So this right here is a acute angle, Now when you label a point that exists outside, is every single one of these other points over here. Now it does not include S, it does not include X, and it does not include R. They lie on the angle. So our exterior angles, if you said T or Q or U or V, those are your points, exterior points. Now our next one, T, X, V, our initial thought is a right angle, and you will be right. But it's not a right angle because it tells us it's a right angle. We're assuming it's a right angle. But here's the argument for this, and this is when, as we learn more about geometry, we got to make sure we have something to back up the argument we're making when we make claims like that. Is that a right angle? Why? Now, you can always assume a straight angle. RXV is a straight angle. We can always assume that's 180 degrees. For sure. No doubt on that. Now, over here, there is a 90-degree angle, TXR, on this side. So that is 90 degrees. So then, using a little bit of logic, if this is 180 and this is 90, what if I subtract this? I'm left with 90 degrees. So the distance between these two has to be 90 degrees. So you can go ahead and make that assumption that it is right. But we only can make that assumption because we have this block right here, this little square in this corner on this side. Now, points that exist outside of this angle over here will be R or S. You could say either one of those two. Now, let's look at our last angle here, S to X. So S, X, and then we're going to V over here. This big one right here. Hopefully, you said obtuse. And then you're going to say, hey, what angle exists outside of, or what points exist outside of that? The only one that exists is our R. That's our only exterior point to that angle. So, let's talk about other ways to classify these, or not classify the angles, but name these angles. So again, like we saw earlier, angles can be named according to their 3-letter combination. So let's talk about this angle right here. This angle right here can be called angle A, B, D, A to B, and B to D. Or you can also do it in reverse. You could say start at D, then go to B, and then A. Either way, as long as the B is in the middle, we are good. But another name for both these angles will be angle 1. Understand, these numbers right here are not representing the measure of these angles, but what they are representing is just a name. Like, hey, that's that first gap, the second gap, the third gap, the fourth gap. We're going to call that angle 1 because this 1 represents this entire area right here. This 2 represents this entire area up here. So we can call it, name them that. So when knowing that, the question is, what is the angle that shares both FE and FG? So there's two angles that share only FE, and there's two angles that share FE, and two angles that share FG. But there's only one that shares both of them. So we'll first look at the individual ones that they share. So FE, so this ray right here, touches two angles. It has our angle 5 up here, angle 5, so that's one of them. And our angle 8 down here, our angle 8 down there, angle 8. For our FG right here, FG, it has angle 7 as an individual angle, but it also does share angle 8 as well. So that's the one angle they both have, they both share, is angle 8, because it's made up of both of those. Alright, so that is important because we're going to talk about other things that are related to that. So when we look at congruent angles, we talked about congruent, the word congruent. Congruent means same. So they're the same angle, that means they have the same measure, or they equal each other. So here we have angle QTR is congruent, remember there's a congruent side, to STR. So this is the written way to say things are congruent. But how do you see it in a picture form? Well, here's the picture of it. Even though it looks like one big arc, they're actually two individual arcs. They're saying that this angle right here, oh, my curve's a little weird. This angle right here and this angle over here are congruent. So you'll see the same one mark to determine that, hey, this angle is congruent to this angle. Similar when last time we saw congruent, I'm talking about a segment that was bisected by a midpoint, and the midpoint formed two congruent angles. So they put these one little marks saying, hey, these two sides are congruent to each other. Well, with angles, it's very similar. You have these two angles that are congruent to each other, and they'll mark them like that with the same little curve. Now, adjacent angles are angles that are next to each other. They're right next to each other. And not only are they next to each other, but they also share one common side. They share this side. So these two angles right here are adjacent to each other because they share the side, of course, and they share the point, the vertex. Now, all adjacent angles are not congruent angles. You can easily have an angle with a bisector right here, right there. So these two angles right here, I'm going to put the angle mark in red. This angle and this angle, they're two different angles. They're not congruent. They're not the same, but they are adjacent angles because they share this side right here. This represents one angle, and then that same side with the other ray represents the other angle. So same thing over here. These just happen to be two congruent angles, but they're also adjacent. Now, bisector of an angle, previously when we talked about this, we talked about the segments, and the midpoint right here, our midpoint is considered a bisector because it split the segment in half. Well, for angles, the bisector is a ray. So in this case, the ray is the one in the middle because it does happen to cut this in half. So our original angle QTS was bisected, so they abbreviate as BIS, bisected by ray TR, so TR with the ray symbol above. This angle was bisected by this ray right here, forming two smaller congruent angles. So that's what bisector means, split in half. This is what cuts it in half. Let's just kind of do this example right here. So first, we're going to name two adjacent angles, so two angles next to each other. And you have multiple combinations. I'm going to go with angle SXT, so SXT, this angle right here. I'm going to do it a different color. An angle TXQ right here. These are two angles that are next to each other, and they share the one side. On the picture, you can see that. But just looking at the letters only, they both have T and X in it. That's because they share that. And they both have X in the middle because that's their vertex. So they're adjacent. Now when we look at congruent angles, there's two sets of it for sure on here. The first one is our given one. Right here, when they have the same mark, you can go ahead and assume those are congruent. So angle QXU, and angle is congruent to angle VXU. Those be U itself, V. Now you can say UXV as well, but I don't know, habit. I always try to keep the size they share in the same spot, XU, XU, and I switched out the first ones. But you can easily say UXV, and it's still talking about the same angle. Now when we talk the other set, by the way, let's talk about the other set that exists, are the two right angles. Remember, we had a right angle right here, so we can go ahead and assume this right angle over here as well. So we say angle RXT is congruent to angle BXT. Those are also congruent to each other because they're both 90-degree angles. All right, so looking at the last one, it's just like that, because we know there's two sets of congruent angles. There is technically two main angles that got bisected. So we'll do with the easier one right here. So they ask, what is an angle that is bisected, and what was the bisecting ray? So because these two angles are congruent and they're adjacent, so they're congruent and adjacent, we can go and say, hey, the angle that was bisected is angle QXB, the original whole angle, both of them put together. What cut it in half was this ray right here in the middle, our ray XU. So you'll see that happen right there. And then the other one, of course, is our straight angle RXV that got cut by XT straight up and down in the middle. All right, our last example here is a little bit of actual math work here. So let me pause and take a minute to look at that. But the given information is saying that XU, right here, bisected QXV, as we just kind of talked about ourselves. I took the exact same one, so you can see it still and not be completely different and change a lot. All right, they tell us that VXU right here is 4x plus 15. That's the measurement, and that's what this little m stands for. M stands for the measurement. That's where you just put the m because it's a long word. And when they talk about measurement, they want actual value. So if the measurement of XUV is 4x plus 15, and the measurement of UXQ right here is 8x minus 5, the question is, what is the measurement of UXQ? So they want to know what's the actual numerical degree. What is the degrees of this? So we have some number degrees. They want to know that. Now, looking at these two problems, we do know they're congruent and they're adjacent, but that's not as relevant as the congruent part. But because they are congruent, we can set those equal to each other. Remember, anything that's congruent is equal to each other. So we say 8x minus 5 equals 4x plus 15. So we're going to do a little bit of math here. We're going to go ahead and subtract our 4x, so minus 4x minus 4x. That gives us, right over here, that gives us 4x minus 5 equals 15. And then we're going to add 5 to both sides, plus 5 plus 5. These is 4x equals 20, and of course we will divide by the 4 at the end. Finds us that x equals 5. Is that our answer, y'all? No. Remember, that's a answer, but not that answer. They tell us x is 5, but the question was, what is UXQ? So we're going to substitute that in. We're going to have 8 times 5 minus 5. So we got 40 minus 5. We end up getting 35 degrees. That's our answer. So this angle, the measurement of angle UXQ equals 35 degrees. All right. The last couple of vocabulary we're going to talk about and a couple of examples to look at. We already talked about adjacent, but I would really want to pound this down when we talk about this. As you can see right here on the non-example, these are two angles that are technically next to each other. You can argue that, hey, these angles are next to each other. True, but you cannot argue that they are adjacent angles because they do not share one side at all or the vertex. Here, these two are adjacent. They're not equal. This is a lot smaller than this one over here. I'm going to say a lot, but smaller. But they do share this side right here, and they do share this vertex right there. So these are an example of adjacent angles. Not always congruent, but they definitely have that side. These do not. A linear pair is just that. It's a line that together they make the entire 180 right here. So we don't have to know the measurement angle 1 or angle 2, but what we do know is that together they form this entire line right here, even though they're two individual angles right there. So we got this angle. I'm going to change the color so we know to represent there's angle 1 and of course angle 2 right here, but together they make 180. So sometimes you will have the numbers 60 and 180. So they are a linear pair. We will later talk about angles that are not that equal 180 together, but they're not linear pairs. So you could have an angle like that, and another angle, kind of similar to this idea. This could be 60 and this could be 120, but again, they're not next. They're not together. They're not adjacent. So you see, they have to be adjacent. That's part of the difference. They're adjacent angles, so they have to share a side, and then together make 180 degrees. Pick the line. Now, vertical angles is my favorite kind of angles right here. Vertical angles are two angles that are across from each other. That's all it really is. It's two angles that are across from each other, and they're formed by intersecting lines. That's the key part, intersecting lines. They're intersecting lines because here you have a line, but then you have two different rays that go from it. So this is not two intersecting lines. It's a line and two rays. But here we have two intersecting lines that go across each other. What makes these angles unique is that these angles that are vertical to each other are congruent. So angle 1 and angle 3 are the same measurement. And then angle 2 and angle 4 over here are also the same measurement. Now, angles sometimes can look, pretty similar right there, and they can look barely vertical. They're barely vertical. But the idea is still the same. These are still two lines that intersected. So that means regardless of how big this angle is, how little this little angle looks, these are still vertical regardless. So, all right, y'all, that's it. Hopefully that helps out, and I'll see you another day. Bye.